Welcome to the first day of Unit 9, our unit on quadrilaterals. You can put in your planners the homework after you watch the video today is pages 5 to 6, and then you should also be studying your parallelogram reasons, and we'll talk about that momentarily. Today we'll be working with parallelograms. So unless you're a cohort A person who is absent both Monday and Tuesday, everyone should have their green study cards now for helping you memorize all of your different quadrilateral properties. So each day we will add on a different quadrilateral and you'll have to study those to memorize them. So part of what you should be doing tonight is memorizing your parallelogram reasons. So each of these starts with parallelogram implies. That's why it's just written big for all of them. So when you memorize, you'll fold back the right side, just like we did with the beginning proof reasons, and you'll say parallelogram implies, and you'll have to name all 5 of them as you flip them out. So parallelogram implies opposite sides congruent. Parallelogram implies opposite sides parallel. Parallelogram implies opposite angles congruent. Parallelogram implies the diagonals bisect each other, and parallelogram implies consecutive angles supplementary. So part of your homework for today is spending the time it takes to make sure you have those memorized. Now I think as we learned with early proofs, I think everyone knows how important it is to memorize those reasons. There will not be any pause in this unit for people that don't get on board. You'll just be left behind. So it is important that you memorize those reasons and that you do them when we need you to. So today, part of what you'll be doing as your homework is making sure you put in the work to get those 5 memorized. So, properties of a parallelogram. So if a quadrilateral is a parallelogram, then one thing we know is that the opposite sides are parallel. And you can be filling that in right in the gray box in your notes packet. If for some reason you don't have the notes packet yet, you can put this on a separate sheet of paper, or there's a digital version on Schoology in the class materials folder under Unit 9. You can print out the pages for today. So parallel, we mark that in our picture with arrowheads. So the single arrowhead represents those two are parallel to each other. The double arrowhead represents that those two are parallel to each other. And that's one of our parallelogram reasons we saw on the previous slide. Parallelogram implies opposite sides parallel. If a quadrilateral is a parallelogram, then we know the opposite sides are congruent. And we've been marking congruent things for a while now. So again, that's one of your reasons that you will have to memorize on your green card there. Parallelogram implies opposite sides congruent. Next one, if a quadrilateral is a parallelogram, then the diagonals bisect each other. If things bisect each other, that implies that there is a midpoint for both of them. So wherever they're crossing, that'll be the midpoint for both. And if that's the midpoint for both, that will imply 2 congruent segments and we'll have 2 sets. So we won't get those markings right away, but we will be able to, in a couple steps in our proofs, eventually be able to get those sets of segments congruent. So each of the diagonals gets cut in half. Number 4 in a quadrilateral, if a quadrilateral is a parallelogram, then the opposite angles are congruent. And we have in the picture there the opposite angles marked up, so the ones essentially that are diagonal from each other in the picture. And when we say the opposite angles, we mean the entire angle. So if you had like a diagonal drawn in, it would be like that whole angle is equal to that whole angle. Now, one thing while I'm thinking of it, if we ever, we'll always be able to abbreviate parallelogram with this symbol. Okay, so if you ever have to write parallelogram, you can kind of use that symbol that looks like a parallelogram. And the other thing I want to mention while I'm thinking of it, say we have parallelogram ABC, oops, not ABC, B, ABCD. When you label a parallelogram, you have to label going around in a circle. So you start here with A, and then you can go in either direction, B, C, D. So I'm going to go B, and then C, then D. So make sure as you're labeling it, you go around in a circle. Don't go A, B, and then jump over here for C. Okay, you got to go in a circle as you go around labeling it. All right, the next one is not one of our reasons that we'll use in proofs, but is something we'll see in algebraic problems today. So if you have multiple parallel lines cutting a transversal, and you know that the parts of one of the transversals are congruent, on the other transversal they will also be congruent. So from A to C and C to E, those are congruent. Well, we know then over here that B to D and D to F have to be the same. They won't match A to C and C to E. They'll be different amounts than that, but they'll be the same as each other. So maybe this is 3 and 3, and these are like 4 and 4 or something. Now, in 6 and 7, the last reason from our green card that we haven't talked about yet is about consecutive angles. So let's first talk about what consecutive angles are. If you go around in a circle with the angles in your parallelogram, consecutive are just one right after the other. So like J and K would be considered consecutive angles. K and L would be considered consecutive angles. L and M and J. So one right after the other when you go around in a circle. Now, in a parallelogram, the reason we have that a parallel is that a parallelogram implies consecutive angles are supplementary. So within algebraic problems, we will use this one most often. This one doesn't get used a ton in the proofs, but like something we know is that angle M plus angle J would have to equal 180, because those are an example of a set of consecutive angles in our parallelogram, so we know they are supplementary. So today's focus is on algebraic problems with parallelograms, and then as the unit continues, we will do some proofs with them, and then each figure we will see some algebraic days with the figures, as well as proof days with the figures. So at number 1, on the bottom of page 2, we've got some algebraic expressions for angles, B and D. So from our green card, we have two different angle things. We have parallelogram implies opposite angles congruent, and parallelogram implies consecutive angles are supplementary. So we've got to decide which one we're working with here. Well, D and B are across from each other in the parallelogram, so those are opposite angles. And we know opposite angles are congruent. So the equation we'll set up is x plus 15 equals 135 minus x. And to go through and solve, we'll collect all the x's on one side and the constants on the other. So we'll add x to both sides maybe. That'll give us 2x plus 15 equals 135. We can subtract the 15 over. That'll give us 2x equals 120. And we can divide by 2, and that'll give us x equals 60. In this course, whenever you find a variable, reread the question. See if that's what they want, or if they want you to sub in. We did not want just x, we want to find the measure of angle A. Well, we don't have any labels for A, but let's sub in the x for the ones we know. So 60 plus 15 will give us 75, and 135 minus 60 will give us 75. And that makes sense because those opposite angles should be congruent. Well, to find angle A, let's maybe call the variable that's not in the picture right now, let's call it y. We have to use our property that consecutive angles are supplementary. So we know y plus 75 should equal 180. So we'll subtract the 75 over. That'll tell us that y is equal to 105. So we've now found that the measure of angle A is equal to 105 degrees. So we had to use two different parallelogram properties to eventually get the answer in this one. All right, next up we want to find the values of x and y. Each of those expressions are labeling the parts of the diagonals. So we want to be thinking of our diagonal reason with a parallelogram, that a parallelogram implies diagonals bisect each other. Well, if they bisect each other, that means that point A is a midpoint of both of them. If A is a midpoint of both of them, then we have two sets of congruent segments. If they're congruent, that means we can set them equal. So we'll have 2x plus 5 is equal to 5y. And then the other one will have 7y minus 16 is equal to x. Notice we have two equations that have two variables in each of them. So we want to be thinking elimination or substitution. The way these equations are set up, it's set up nice for substitution because in the right-hand equation, x is already by itself. So let's take the expression that x is equal to, and we'll sub it in parentheses where x is. So we'll have 2 times 7y minus 16 plus 5 equals 5y. We'll distribute the 2 to give us 14y minus 32 plus 5 equals 5y. And we want to collect all of our constants on one side and our variables on the other. Before we do that, we've got some like terms there. Let's combine those. So 14y minus 27 is equal to 5y. It'll be quickest if we get the y's over to the right, so we'll subtract 14y from both sides. And that'll give us negative 27 equals negative 9y. And to finish it off, we'll divide both sides by negative 9. And that'll give us 3 is equal to y. Well, in this course, whenever you find a variable, go back up, reread the question, see if that's what we wanted. We wanted to find x and y, so we are halfway there. But then we have this 7y minus 16 equals x equation. You could really plug it into either equation. This one looks like it'll be less rearranging, so y was part of our answer. We'll sub the 3 in for y in this equation so that we can solve for x. 7 times 3 is 21. And if we subtract, we'll get 5 is equal to x. All right, moving on to page 3. So we've got parallelogram MATH. So let's draw ourselves a parallelogram. And we're going to have MATH, and the measures of A and T are in a 2-to-1 ratio. So that means of A and T, A should be the bigger one. So of our angles here, let's put the A here. And if I put M here, we want to make sure we go around it in a circle. So M, A, T, and then H. Whenever you have a ratio, you want to just stick X after each of them. So we're going to think of A as being 2X. and t as being 1x. Well, we're working with angles. So on our green card, we have two angle properties. Parallelogram implies opposite angles congruent, and parallelogram implies consecutive angles supplementary. Well, these are an opposite. A's opposite angle would be h, t's opposite angle would be m. These angles are one right after the other, so they're supplementary. So we want to add them and set them equal to 180. We'll combine our like terms. And we'll divide by 3, and that gives us x is equal to 60. Well, we just found a variable. Let's see what they wanted in the question. They wanted the measure of angle m. Okay, so that means we're not done yet. So let's fill in what we know for x. So that means this one's 60 and this one's 120. Well, m is opposite angle t, and we know in a parallelogram that opposite angles are congruent, so m is just 60. So the measure of angle m is equal to 60 degrees. Remember, that little m in front of the angle just stands for measure. All right, so we've got 4 parallel lines here. So we'll put our little arrowheads on these to show they're parallel. We've got the 3 on the left are 2. So the property we saw on a previous slide was if those are all 2 and they're in between lines that are parallel to each other, then these should all be congruent. Well, they told us 2.5 for the one section, so each of these is 2.5. And we just want to find from E all the way to H. Well, that's just 3 2.5s. So you can either add up 2.5 3 times or do 2.5 times 3. So we should get 7.5 for EH. So our properties of a parallelogram, again, these should be something that you're studying tonight until you have them memorized. Okay, shouldn't take too long. So parallelogram implies opposite sides parallel. Parallelogram implies opposite sides congruent. Parallelogram implies opposite angles congruent. Parallelogram implies consecutive angles supplementary. And parallelogram implies diagonals bisect each other. So study your card, then get someone. Okay, could be a parent, a sibling. If you don't have someone in the house, get on a video chat with someone, maybe someone in the class, and they could quiz you and you could quiz them back. But spend the 10 minutes or so it'll take to have those memorized because we will be using them in our proofs tomorrow. All right, down at the bottom of page 4. So we're given an expression for AB, 2x plus 1, and DC is 4x minus 19. So those are both sides in our parallelogram. The two things we know about our sides in the parallelogram are opposite sides are parallel and opposite sides are congruent. Well, those are opposite sides, so we know that they are congruent, so they should be equal to each other. So we can do 2x plus 1 equals 4x minus 19. And we'll just work to get the x's by itself. Maybe we'll collect the x's over on the right. We can add the 19 over, giving us 20 equals 2x. And divide by 2, and we get 10 equals x. In this course, anytime you find a variable, reread the question, see if that's what we wanted, and in this case, that is what we wanted, so we're actually done. All right, next one, AB is x plus 3. And BC is x minus 4. And then they tell us the perimeter is 6x minus 20. Well, if AB is x plus 3, because parallelogram implies opposite sides congruent, we know DC is also x plus 3. And if BC is x minus 4, we know AD is also x minus 4. So we have two different ways we can express our perimeter, and we'll just set them equal to each other. We could take it from our picture, and we can say x plus 4 plus x plus 4 plus x plus 3 plus x plus 3 is equal to what they told us the perimeter was, 6x minus 20. Now on that left side, I could have written that in a shortcut way. X plus 4 plus x plus 4 is also 2 times x plus 4. So I could have written it as 2 times x plus 4 plus 2 times x plus 3, again, equals what they told us the perimeter was. So we would want one of those two things written. So let's say we took the top one. If we combined our like terms, we would have 4x's. 4 and 4 is 8. 3 and 3 is 6. 8 and 6 would give us 14. Actually, I miswrote that. Hold on one second. These should be minuses. So that won't be 14. Sorry, I carried that over wrong from the picture. Okay, so fix that on your paper. Let's try this again. So if we do negative 4 and negative 4, it's negative 8. 3 and 3 is 6, and negative 8 plus 6 will give us negative 2. And then that equals the 6x minus 20. Maybe we'll get the x's over on the right. So we'll subtract 4x from both sides, giving us negative 2 equals 2x minus 20. We can add the 20 over. I'll bring it over here. That's going to give us 18 equals 2x. And we can divide both sides by 2, and that'll give us 9 equals x. Reread the question. That's what they wanted us to find, so we are good. All right, so what you have to do the rest of the day now, you have your packet pages for homework, and then you should be spending at a minimum 5 minutes to study those 5 proof reasons. Okay, and it might take a little longer than that. You need to study them until you have them memorized. Find someone to quiz you. Okay, make sure when you walk into class tomorrow that I should be able to quiz you and say parallelogram implies, and you should be able to list the 5 things that a parallelogram implies. Okay, if you don't know those when you walk into class tomorrow, you will be behind in this unit, and you're going to be struggling to catch up the rest of the way. Okay, so do yourself a favor, take the 10 minutes or so that it'll take to memorize them, study them for a little bit, a few minutes, and then have someone quiz you, and have them keep quizzing you until you can name all 5 of them twice in a row. Have a great rest of your day.